Now I'm going to dump this program into this freedom board, and before dumping this program I need to say something. And this pin diagram, in this pin diagram we can see what are all the analog channels and what is the digital to analog channel that is available for this freedom board. And we can see here this all these set of pins are for analog channel, and these are also for analog channel, and this is the one which is used for DAC output. So this pin will give you the analog output, that is from conversion from digital to analog value will be obtained from this pin, that is PTA30. And this is the analog channel. And now we are going to see the KL25Z pin out of this one. As we can see here, this ADC0 is assigned with the pin PT20. So PT20 pertains to ADC0. So for giving analog input, we need some analog voltage. So analog voltage can be given in either way. We can give analog voltage, or we can give a square wave, or we can give sine wave, which is varying sinusoidally. So any type of analog wave can be given to this ADC channel input. Now in this, as we don't have any provision to give some random analog voltage, we are going to use the generated analog voltages. So we are going to give this analog voltage to this pin, or we can give the LED output. So this LED, blue LED is connected to this PTD1, so which is the fifth pin in this column. So this pin can be connected to this analog channel, so that this analog channel will be fed with the square wave that is being generated by this LED1, or this analog channel can be fed from the ground potential, so that we can get only 0 in the digital count. Now as of now I am going to connect this analog channel to the DAC channel. So this is the connection pertaining to this one. This DAC output is connected to the analog input. Now we are going to see how the program is getting executed. I am going to dump this program, and you can see the LED is blinking at a very fast rate, and which we cannot see by our naked eye. Now we are going to debug this program. So I am directly going to the very last step here, and we can see here that R5 will be holding the analog to digital converted value, and R1 will be holding the value that is being sent to the digital to analog converter. Now I'm going to run it step by step. So we have the digital value to be FFD, that is given to DAC, and we have been getting a value from ADC conversion by, that is FFB8. So ADC is right now in 16-bit operation, and the DAC needs to be given only with 12-bit of data. So we are getting the values like this. And now what I'm going to do is I'm going to connect this ADC channel to a ground potential, so that I will get only 0 for each and every conversion. So now this ground pin is connected to the ADC channel input. Now we can see that the R5 value is always 0. And now I am going to connect this ADC to the LED output. So LED output in the sense 1, 2, 3, 4, 5th pin. So it is the connection like this. This ADC input is connected to the LED output. LED will be getting blinked at a regular frequency, so that this will generate a square wave. So this square wave is being fed to this ADC now. Now I am going to change my point of execution. I'm going to stop the execution here. So you can see the LED is on now, and LED is off. LED is on, LED is off, LED is on. So LED is on, we are getting a data, digital data of FFD8. When the LED is off, we are getting a data of 313. So again FFD8, now 2FF. So it is around 300. So in this way we can check the working of ADC and DAC without the help of any external analog signal generation unit. And now if I am stopping this debug session, so this LED is going to be blinked at a very faster rate. Now if you want to change the frequency with which the LED is going to be blinked, we need to change the frequency of operation of ADC. So now I am going to change the ADC frequency. So I'm going to set it as FD instead of 9C, so that so now we can see the change in the LED blinking rate. So now it has reduced. So we can notice the LED on and off regularly. So with this I'm going to stop this video first. So I think this video has given you a slight introduction to ADC and DAC of this Freedom board. I'm going to stop this tutorial right now, and thank you for watching all my tutorials till now. So these tutorials are just to give you an insight of how to do programming in assembly language for these ARM controller boards. And thank you for watching. Thank you very much.